Hello. If you're watching this video, it might be because the internet kept on dipping during class. I know I said on Monday that I'd have it up that day. I stuck by my word that I will get it on Tuesday because, hey, it's Tuesday, I'm putting it up. So, anyway, without further ado, we're going to go into graphs, okay? So, let's talk about graphs, okay? When you think of graphs, you might normally think of these kinds of guys, right? You see them in boardrooms and like big corporate offices. You go like do 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 do. Maybe one of these. They do like this, right? And these are certainly graphs. There's no arguing that, right? They're graphs, but we also know there's pie charts. Those are graphs. There's all kinds of graphs. Now, all these things, right, that look so different from each other, but we kind of have an idea they do the same thing, right? And in math, we mostly define things by what they do, what their role is, what their purpose is in math, right? So, here is your definition for a graph. A graph is a way to present data. Now, data isn't just that thing that you pay for on your phone. Data is any collection of numerical information. Any information that's numbers, and you collect it, and it's all kind of describing the same topic. That's data, right? To present data using well, actually, I'm not going to say pictures, using shapes and or symbols, right? And so we're not just presenting data, like I can't just like draw the number 3 and put a triangle next to it because there's no meaning here, right? Now if I'm using to say there's 3 Doritos, hey, we might have ourselves a graph, right? 3 Doritos, 2 we'll say Pringle chips, right? The point being, that's kind of like a graph now. These are graphs. Here's some other graphs you may have seen in your day-to-day life. We have a thermometer. You might say thermometer isn't a graph. That's like a thing. That's not a picture. It's like a real object in the real world. Well, it uses shapes, doesn't it? That shape being a straight line that has different numbers along the length of it that tell you what temperature it is, either in the room or in someone's mouth or wherever, right? Maybe in a steak, right? There's meat thermometers. Another graph might be this guy. You probably stare at this thing more than you stare at the teacher, right? This is a graph because, right, we've got data, we've got numbers, that's numerical information, and the arrows tell you which numbers are currently describing the time of day, right? An arrow, that's a shape that means, hey, look at this. A circle, that's a shape that means turning, right? Like the turning from day to night. Okay? So this is also a graph. The circular shape of a clock communicates. These are all objects we've seen, kind of more common things. Let's say a Facebook post by Mr. Fraley. post itself is not a graph. It's just some text. I might post a graph. Might say shared this photo or this image or this picture. They'll say picture, I'm going to say image, whatever. Shared this picture. I might share a graph. But this isn't the graph I'm talking about. The real graph here is underneath. The graph shows you maybe how many people liked the post, right? Maybe one person liked it. It might also tell you how many people didn't like it, right? A little angry reaction, right? Maybe that's 1,000 people didn't like it. It can also tell you how many people interacted with it, like with it says like 3 comments, right? This section of the page, not just for Facebook, but any social media, this is a graph, right? It's a picture that is used to represent or communicate numerical information. So, that's a graph, because it does those things, right? So that's a graph. Now, what about tables? A table is a similar idea. But let's say we have a table. I don't mean a table you eat dinner at. I'm talking about one of these kinds of guys. Right? Maybe there's a hot new streaming service to stream all your movies, right? It's like a film strip or whatever. I don't know. It's called Streamo, right? And there are multiple payment models. You can do $30 per month, right? No, sorry, get my numbers straight. You could say it's $12 a month, or we could say $30 for 3 months, or $75 for a year. Okay? And let's say we've got our months: January, February, March, April, May, June, July, so on and so forth. You'd pay 12 or 24 or 36, right? That money's going to pile up through the year. Right? Or, you could go a little more slowly. Here you pay once, you're good for 3. No, I'm going to do this. You pay once and you're good for February and March. Then you pay again in April, and then you're good until July, right? And so now you've only put $90 into it versus the $84. Whereas maybe you're more interested in this. $75 to cover you for the whole year, right? But point being, this here can be a way to help us make a financial decision. Maybe I'm only going to sign up for a Streamo to get 1 month, and I'm going to quit my subscription right afterwards because I only care about just one show, right? Maybe there's going to be several things coming out. I'm kind of interested in it, right? Maybe I'm not sure, so I'll pay and I'll see if anything more comes out in the next 3 months. If nothing does, I'll cancel it before the 3 months are over. Or, you know what, maybe I'm all on board. Maybe Streamo is backed by, think of like Disney Plus, right? Might choose to go for the whole year, right? Because it comes from something that, where you're going to be getting stuff you're interested in on a continuous basis, okay? So this table can help you make an informed financial decision. Next. So that's a table, right? And if you took that information real quick, I want to really say one last thing on the topic of Streamo. If you're to look at what you're paying, this here might be the $20 a month, the $12 a month, right? You pay 12, then you pay 24, then you pay 36, then you pay 48, right? Versus another model where you might pay 30 and it'll be good for a while, and then you pay 60 and it'll be good for a while, and then you pay 90 and you're good for a while. Or maybe you'll just pay 75. And you're good for the whole year, right? You know, this is going to be a low price for a short while. It's kind of a moderate, kind of a few savings. And this is a good fixed rate for the long term. So, it's a way we can understand and think of our values. Okay? You can present them like this as well. Next. Let's say we're driving. You know what? We're going to be driving in New Mexico. So we've got, you know, mountains, right? And you're driving down the road, right? It's always hot there in New Mexico. And anyway, so you're driving down the road, right? And you see a sign on the side of the road. Those green signs, they always put on the side of freeways. And when you look at it, it says this. You know, maybe 300 miles to Denver, Colorado, and I don't know, 800 miles to Phoenix. See that information right there, okay? And you look at the dashboard of your car. Say we're looking over, looking down it. Got our steering wheel right here. And you look and you see the needle's pointing to 60 to say that you're going 60 miles an hour. And then you look over here and your clock says it's 6 o'clock, right? So we got all these things we can look at when we're driving. Well, you get a phone call. It's from your friend who you're going to go visit in Denver. And your friend says, hey, when are you going to get here? I'm hungry. Let's get some dinner, right? So, your friend says, the restaurant closes at 10 o'clock. Okay? 10 o'clock at night. The restaurant closes at 10 o'clock at night. And your friend asks you, hey, can you make it? Are you going to be able to make it on time? Are we going to be able to have dinner together? Well, that's a good question. It's 6 o'clock right now. You're 300 miles out of Denver and you're going 60 miles an hour. Well, all this information together can help us answer the question. We use this one little equation here to help us. We're going to say, this is always true, distance equals rate, that's to say your speed, times time. Your distance is the rate times time. Your rate is your speed, okay? And so we look and we know that we're going to go 300 miles. So 300 is going to equal my rate, which is 60, times t, which is my time. Okay? Well, to find t, to know how long it will take to get there, where t is time, so we know the time. We'll divide both sides by 60 using algebra. 60 is multiplied times t. We'll separate it by dividing on both sides. 300 divided by 60 is 5. So my time is 5 hours. Well, it's 6 o'clock now. What time will it be in 5 hours? That's right. It's 11. It'll be 11 in 5 hours. So, can we make it there by 10 o'clock? No. We'll make it at 11. Now, that question had a lot of parts to it. A lot of information spread around. None of it's really on a piece of paper in front of you, like what you think of in math class. These are all on road signs, or on your speedometer behind your steering wheel, or your clock right there, your friend talking to you on the phone. These are all different kinds of data, different kinds of information. We might see what we call up here, we call this verbal data, or verbal data, right? It's spoken. Verbal means like language, like words. Think of verbal communication. Verbal data. This here, we got an arrow pointing to a number. This here is actually a graph. We got shapes, we got numbers, working together to communicate. That's graphical data. Then here, this right here is a table. It's tabular. We call this tabular data. Okay? And lastly, but certainly not leastly, this clock here is giving us numerical data. By telling us it's 6 o'clock. Oh wait, one more thing. There's numerical here. And lastly, we have algebra. Algebraic information. So information can take many different shapes. It can be spoken to us. It can be shown to us on a graph. It can just be a regular plain number. It could be organized on a table. Or we can process it using algebraic thinking. Okay? But there's all the different ways to process information, and it's important to understand all of them so we can answer real-world questions. Like, if we're going to be able to have dinner with our friends. Okay? So, we're going to look at one more example. In this example, we're running track. So, running. We love running, right? He's running, he's got a little jersey on, right? He's running track. And your other friend is also running, and you're racing. You're trying to beat your friend in this race. So, but your friend came out of the gates really fast and he's getting really tired. He is not doing so hot. He's trying his darndest, but he came out of the gates too fast. He's starting to slow down a little bit. We've got our finish line ahead. Now, you are 140 meters into the race. You've been running for 140 meters. Your friend, though, has been running for 200 meters. And this is a 500-meter race. Your friend's starting to slow down. You've kept it cool and consistent 3 meters per second. Your friend is slowing down to 2 meters per second. He's a little slower than you right now. Not by a lot, but a little. He's going 2 meters per second. And you want to know, is it too late? Or can you beat him? Well, let's consider our options. To figure that out, consider our equation from earlier, distance equals rate times time. So let's look here, and how much distance do I have left to run? Well, I have 360 meters left to run. 150 minus 140, that's 360, that's my remaining distance. And that's going to equal my rate, 3 times the time. Whereas my friend over here, he's got to cover 300 meters. And he's going 2 times t, right? So whoever t is the lowest will win the race. That's the least time. Well, all we do to get the t on its own, who's bothering him, the 3, we divide the 3. And 360 over 3 is 120. That equals t. And here, our friend, 300 equals 2t. Divide both sides by 2. And then we get 150 equals t. So we're going to take 120 seconds. He's going to take a whole 150 seconds. He's going to be beating that finish line 30 seconds after we do. So we're going to win. Right? So I gave you this example to think about. But let's consider this shown slightly differently, using graphs. Let's say we've got this here, our graph. We are starting at 140. So say we start right here, 140. And our friend starts at, it's about right there, is 200. And he is not going super fast. Unfortunately, we're doing a little better than he is. Now, the finish line from earlier is about right there. Okay? So that's our finish line. And this graph here, by showing the data, by showing me going up more quickly, he's going up more slowly, he's going to arrive way later in time than we are. Okay? And a graph here can not only show us when either of us will hit the finish line, it can even show me when I'm passing him up. That's going to be where our line intersects. So if you can plot this in a graph, we can see that data as well. Right? So this graph can show us things that would not be immediately obvious when just shown information like this. So anyway, and you know what, this here with these runners and the finish line, this here, these two runners, this is technically still a graph because it's images used to present information, numerical information, like how fast people are running, how close they are to a finish line. But it's more illustrative, right? This here, although more abstract, has more information packed into it. But they're both good graphs, and they can both answer different questions for us. Anyway, thank you for watching. You have a good day. Stay safe.